Yeah, so we shall start the class today. So the topic is multiplexers. So there is another combination circuit. So another example of a combination circuit. The topic today is about multiplexers. So just like decoders, we'll see about the multiplexers. So what is a multiplexer? Okay. So this is okay, and so we'll see the definition of multiplexer, and we'll see the truth table of a multiplexer and what this multiplexer will do. Okay, and so we'll see how the Boolean functions or any circuits are designed using multiplexers. So this is one of the most important combination circuit that it is used in day-to-day life. Okay, so nowadays the real-time workers or real-time work, so the industries so will prefer this multiplexer compared to other components. Okay, because this multiplexer, any functions can be implemented with the help of these multiplexers. Okay, and it is a simple one also. So understanding this concept of multiplexer is very simple. Okay, so we'll see a multiplexer. So first of all, we'll see the definition of a multiplexer. A multiplexer is a combination circuit. It is a combinational circuit. Combination circuit that selects so binary information from one of the input lines and directs it to a single output line. Okay, and the selection of a particular input is controlled by selection lines. There is a normal definition what we give here. Okay, so generally it is a combination circuit. So we'll be having multiple inputs. Okay, so we'll be having multiple inputs, and what we have to do, we have to select one among those inputs. Okay, and give that input as output. And selecting these inputs is done with the help of this selection lines. We'll be having the selection lines here, and those selection lines will select one among the multiple inputs. Okay, and that input will be directed towards the output line here. So we'll be having only one output here. So the multiplexer gives only a single output. So multiple input, single output. This multiplexer is a combination device, so which will be having multiple inputs and a single output. So one among the multiple inputs is directed towards the output line here. So you'll be having only one output here. Okay. So what is output? So which is one among the inputs, whatever the inputs we have. So we have multiple inputs here, and one among those inputs will be the output here. Clear? I'm getting my point.
Yes, sir.
Yes, sir.
Okay. So you'll be having
Sir,
yeah. Waiting.
sir. Waiting, sir.
Yeah. Yeah. Okay, so multiplexer is a combination circuit, so that selects the binary information from one of the inputs here, multiple inputs, and directs it to a single output line, and the selection of a particular input is controlled by the selection line. So this is a normal one. So multiplexer is, in general, what we can say here is a multiple input, a single output device here. Okay, and the output is one of the multiple inputs here. Okay, and the selection of the inputs will be based on the selection lines, and these selection lines will select one among the multiple inputs and direct that input to the output line here. Okay, so that is the function of a multiplexer here. So if I have this one, so in general what we can say here is, so 2 power n. Okay, if I have so 2 power n input lines. So for a multiplexer, okay, and so we'll be having only one output. Okay, so we'll be having only one output, and one output is one among these 2 power n input lines here, and a selection of inputs will be based on the selection lines. So how many selection lines we need for 2 power n input lines is nothing but n here. Okay, so selection lines number is equal to n here. Okay, so we'll be having 2 power n input lines. So we can say that 2 power n into 1 multiplexer here. So we'll call it in simple, we'll call it as a mux here. We'll call this multiplexer as a mux. So 2 power n into 1, and in this 2 power n into 1, 2 power n is the inputs and 1 is the output here, and the number of selection lines is equal to n here. So selection lines will be equal to n. Clear? And the shape will be like this. So we'll keep a light wedge shape multiplexer here. So wedge shape. Okay. So if it is a 2:1 multiplexer, so 2:1 and then so 2 power n is equal to 1. So I naught I1 are the inputs here, and S will be the selection line. So we'll be having only one selection line here, and we'll be having only one output. So that is equal to 1. So 2:1 mux. Getting my point? So multiplexer is a combination circuit, so which will be having multiple inputs and a single output here. The output is one among the multiple inputs here, and the selection of the inputs will be based on the selection lines. Okay, so we'll be having multiple inputs here. One among the multiple inputs is directed towards the output here. Okay, and so how to select the one among the multiple inputs here? It depends upon the selection lines what we are using here. So what should be the ratio of these inputs and selection lines? If there are 2 power n input lines, okay, then n will be the number of selection lines here. N will be the number of selection lines. So whatever the inputs we are using, what are the selection lines we are using, we'll be having only one output here in case of the multiplexer. Clear?
Yeah, sir.
Yes, sir.
Yeah. So this is, I mean, these circuits are very important in your future classes, or so what are the classes going on? So in your future, if you want to settle with the core job or software job, so whatever the competitive exams, so these concepts are very, very important. So the basics are very, very important, because if you understand the basics, you can solve the problems. Okay. So try to listen them. So try to listen to the recordings. I think I didn't send yesterday's one. I sent the previous one. Okay. So try to listen them repeatedly. So that will be beneficial for you, right? So try to understand the concepts here, right? So we'll see the how to design a 2:1 multiplexer. Okay, we'll start with a simple concept here. So we'll see how to design a 2:1 multiplexer. Then we'll go for a 4:1 multiplexer. Okay, next we'll see how to implement the Boolean functions or any circuits using the multiplexer. Then we'll see how to implement the higher order multiplexers using the low order multiplexers, just like what we have seen in the last class, like with decoders we have seen, right? So in the same case, we'll see with the multiplexers also, right? So this is the definition of the multiplexer. Now we'll see how to design a multiplexer. So we'll check with 2:1 multiplexer. Okay, first of all, the block diagram. So can you use a normal wedge shape, or we can use this kind also, no problem. So this is Y is output here, and two inputs I0, I1. and S is the selection line, and this is the 2:1 multiplexer. This is the block diagram. Okay, now we'll go to truth table here. Truth table. Okay, so in truth table, so there'll be two inputs. So the first thing is selection lines. The first thing is selection lines. Okay, and the outputs Y will be one among the two inputs, right? So Y will be one among the two inputs. So this is the selection lines and Y. So Y will be in terms of I0 and I1. Okay, Y will be in terms of I0 and I1. For there is one selection lines will be having two inputs. So there is a selection line with selection lines. One selection line, there is two possibilities here: selection line 0 or selection line 1. Okay, if selection line is equal to 0, if selection line is equal to 0, the value of Y is equal to I0. Okay, if selection line is equal to 1, the value of Y is equal to I1. So that is a simple concept here. Based on the selection lines, one of the inputs will be directed towards the output here. So when S is equal to 0, I0 will be the output. Okay, when S is equal to 1, I1 will be the output here. Clear?
Yes, sir.
Yes, sir.
This is the truth table here. So this is the truth table of a 2:1 multiplexer. Now I have to write the equation for Y here. So if I want to write the equation for Y, so in generally I'll used to check for ones here in the column here, output column. But what we'll do here is we need all these I0 and I1, right? So we'll write the equations for each and every term here. Okay, so I0 is equal to, so the equation will be like this. So S dash I0 plus S I1. That is S I1. So Y will be addition of these two. For example, so if I take S as 0, okay, so what is output I have to get here? Y should be equal to I0. Y should be equal to I0. So if S is equal to 0, so this is the equation from the truth table here. Okay, if S is equal to 0, so what happens to Y here? So S dash is S is equal to 0, S dash 1. So 1 into I0 plus 0 into I1. So I'll get a 0 here. So Y will be equal to I0. Okay, hence the functionality is verified. Okay, so when S is equal to 0, I have to get the output of I0 here. So Y should be equal to I0. For example, if S is equal to 1, so what happens to Y here? So it is 0 plus 1 into I1. So Y is equal to I1. If S is equal to, if S is equal to 1. Okay, hence the purpose is survived here. So this is the equation. So this is the equation for 2:1 multiplexer. So now I'll draw the circuit diagram for this. Okay, so Y is equal to S1 S dash I0 plus SI1. Okay, S dash I0 plus SI1. So I'll be having S bar. Okay, so I0 and I1. Okay, so what is Y here? So Y is equal to S bar I0. So this is S bar into I0. This is given to 1 AND gate. Okay, next SI1. This is SI1. This is given to another AND gate, and a summation of these two. So I had to give the summation of these two. So next, this is OR gate here. Okay, this is Y. So Y is equal to S bar I0 plus SI1. So if I substitute the values, I'll get the respective outputs here. So S is equal to 0 అయితే So I'll get the value of y is equal to I naught. If s is equal to 1 either, I'll get the value of y as I1 here. Clear?
Yes,
Yes,
sir.
sir.
This is the logic diagram, and this is the block diagram, and this is the equation, and this is the truth table. Clear? So now we'll see the 4:1 multiplexer. Okay, so we'll see 4:1 multiplexer here. So 4:1 multiplexer. Okay, so first of all, block diagram is fine. Block diagram we can draw like anyways. This will be so wedge shape అనేది లేకుంటే no problem. When we are constructing higher order, so it will be fine. So 4:1 2 power n into, so 2 square into 1. So there will be two selection lines. 2 square into 1 multiplexer. So we'll be having 4 selection lines. So I naught, I1, I2, and I3. Selection lines will be 2 selection lines here. S1, S0. S1, S0. This is a block diagram. Okay, and the truth table will be like this. So 1 selection lines, 2 possible input combinations, 2 selection lines, 4 possible, 0 0 0 1 1 0 1 1, and the values of y will be like this. So 0 0 I have to select I naught as output here. Okay, and if it is 0 1, I'll select I1 as output. If it is 1 0, I'll select I2. If it is 1 1, I'll select I3. That is 2 and this is 3. Okay, so this is the truth table. Now the equation. This is the truth table. So equation will be like this. So y is equal to S1 bar, S0 bar, I naught, plus just add all those things, right? So 0 for bar and a 1 for the normal term here. So this is S1 bar, S0, S1 bar, S0, I1, plus S1, S0 bar, I2, and S1, S0, I3. So this is the equation, and draw the logic diagram for this. So this is the equation. Logic diagram will be like this. So the values are like S1, S0, next I0, I1, I2, I3. This one is not. This is I0, I1, I2, and I3. Okay. So equation is S1 bar, S0 bar, I0. So that is S1 bar, S0 bar, I0. So this 3 given to an AND gate. So మీరు కొంచెం నీట్ డ్రా చేసుకోండి. Okay, and S1 bar, S naught. This is S1 bar, S naught, I1. Second AND gate, S1 S naught bar, I2. So there is a simpler way to draw the diagram. So just you can make use of this technique. And S1 S naught. This is S1. This is S naught, and this is I3. So all the three are given to OR gate because we have to add all these products here. So give it to OR gate. This is equal to Y. Okay, so there is a 4:1 multiplexer. Clear?
Yes, sir.
Right. Now we'll see the Boolean function implementation. So we'll be given a function and we have to implement that function with the help of multiplexer. So what is needed in the multiplexer is, so the multiplexer should have inputs and so we will be having only one output, and we need to use the selection lines. So what are the selection lines that we have to use here, and what are the inputs? So we have to identify the inputs in general. So generally what we have to identify is, so we have to identify the size of the multiplexer first. So after identifying the size of multiplexer, so identify the selection lines, number of selection lines used here, and afterwards identify the number of inputs. So inputs and what are those inputs. Okay, a simple technique is used here. So in order to design or in order to implement any Boolean function with the help of the multiplexer. Okay, so you are clear with this 2:1 and 4:1, right? So you are clear.
Yeah, sir.
Yes, sir.
Yeah. Okay.
Yes,
So now
sir.
what we'll see here is implementation of any Boolean function using multiplexer. Okay, so take down this problem. Implement following Boolean function using multiplexer. I'll not mention any size, just I'll give this function on there. So f of x comma y comma z is equal to sigma of 1 to 6, 7. Okay, so there is a function and I have to implement this function with the help of the multiplexer. Okay, so first of all, check the min terms here. So f of xyz antunnanu ikkada. So f of xyz ante, so what is the meaning of f of xyz? How many inputs we are using here? I mean, how many values are possible here? So what is total number of values possible? 8. So 8.
It's 8, sir.
So but I can't say that. So all the 8 are the inputs here. Okay, so f of xyz is equal to 1 to 6, 7 ichchamante 8 is possible here. This is the combination of xyz will give the values of 8. Okay, but we'll be having so only 4 inputs and 2 selection lines and 1 output, right? So this will give 4:1 multiplexer. Okay, so what we have to do here is, so if I give it as f of xyz here, okay, so if I give it as f of xyz, so xy should be used as selection lines. Xy should be used as selection lines. Okay, and whatever the inputs we are having, whatever the outputs, whatever the output we get here, so that should be in terms of z here. That should be in terms of z. So so the inputs or outputs will be like this. So it will be in terms of Z. So possibilities of Z are Z, Z bar, 0 or 1. So these are 4 possibilities here. Okay, so we'll see how to get these possibilities. So ela vastayi Z, Z bar, 0 and 1. Okay, so if I give it as f of a b c d, so then a b c will be the selection lines and output will be in terms of d there. Okay, output or inputs will be in terms of d. So possibilities of d is like d, d bar, 0 and 1. So any one of these 4 possibilities are there here. So e combinations మాత్రమే ఉంటాయి మనకు. అర్థమవుతుందా? Okay, so if you are given like f of xyz, so blindly what we have to follow is here xy will be the selection lines. We'll be having 2 selection lines here, and the multiplexer is 4:1 multiplexer, and f will be in terms of z, z bar, or the third variable what we mentioned here. The inputs or outputs will be in terms of z, z bar, 0 and 1. Okay, so you'll understand that. So first of all, we have to draw the truth table here. So truth table. So first of all, write all the values of, write the values like the same way. X, Y, that is same, and we'll be having F here. F is the output. So we'll write the same things here. So write this values from 0, 0, 0. The simple technique. One, 0, 1. So there's a 3 combinations here. And you're given a function here. So the function will justify this, what are the values that has to be 1. Okay, so already you are given a function. Okay, and what I told you, so xy will be the selection lines. Okay, so we have to make a division in such a way that so we have to group similar selection lines. We have to group the similar selection lines. So you can check here the values of xy. So group 0, 0. The values of xy is 0, 0, and here also it is equal to 0, 0. Okay, and group the next term here. The selection lines is 0, 1, 0, 1. And group the next term. Selection lines are 1, 0, 1, 0. And group the next term, that is 1, 1 and 1, 1. Okay, and here you are given a function like f is equal to sigma of 1 to 6, 7. So where is 1 here? So this is m naught. This is 0, this is 1, this is 2, 3, 4, 5, 6, and 7. Okay, so 1 to 6, 7 will be 1, and remaining all are zeros here. So where is 1 here? So 1, 2, and 6 and 7. Okay, so because it is a given function, Boolean function here, and remaining all are zeros. Okay, so this is the second step here. So first of all, identify the selection lines here. So our selection lines are x, y. So 2 selection lines. Okay, so divide the truth table into into the similar selection line groups here. So these are similar selection line groups. Okay, and write the outputs which are equal to 1. Okay, and the remaining outputs are equal to zeros here. Now what I have to identify here is I have to compare these 2 values. Wait. Okay, and compare this z with these 2 values f. Okay, and f should be in terms of this z. Okay, so compare these 2. So what, when I compare this f and z, so we check this f and z. Okay, so e group lo matrame, when selection lines are equal to 0, 0. Okay, so what is the value of f? So what is the value of f? So చెప్పండి అండి, కంపేర్ చేయండి f and z ని కంపేర్ చేయండి. Columns of f and columns of z are compared here. Okay, so when selection lines are equal to 0, 0, what is the value of f here?
1.
So check these two values when selection lines are equal to 0, 0, right? So ఈ two values check చేయాలి. ఈ two values check చేసినప్పుడు the value of f is equal to 0 when z is equal to 0, f is equal to 1 when z is equal to 1. The meaning of this is f will be equal to, so compare these two columns మాత్రమే చెప్పాను నేను.
f is equal to z.
f and z మాత్రమే కంపేర్ చేయాలి. f is equal to, so I got the answer. So who is that? Clear లేదు, voice clear లేదు. Yeah, correct. So what is the answer? F is equal to, so compare in normal logical thinking. So what is that value of f? F and z are compared here. So what is the value of f here for these two columns when a selection lines are 0, 0? So what is the value of f?
Z, sir.
Z, yeah. So same thing, right? So if selection line 0, 0 ఉన్నప్పుడు f value and z values are equal here. So f is equal to z here, right? So tell me the value of
f is equal to z bar, sir.
Z inverse, sir.
Yeah, z invert here.
F equal to
0,
1.
sir.
F is equal to 0. It's correct. Because, you know, irrespective of the values of z, we are getting a 0 here. Both are 0. So hence f is equal to 0 here. Okay. And here f is equal to
1.
1. Irrespective of the values of z here, the value of f is equal to 1 here. So these are the 4 inputs of a 4:1 multiplexer. Okay. Z is the first input. I mean, selection line 0, 0 ఉన్నప్పుడు, that will be the first input. So 0, 1 will get a z bar. So 1, 0 will get a 0. So 1, 1 will get a 1 here. Okay, so this is a truth table which is very important here. Okay, getting my point here. So first of all, identify the selection lines what we are using. F of x, y, z. Out of these three, 2 will be the selection lines. So 2 selection lines and will get these combinations 0, 0, 0, 1, 1, 0, and 1, 1. And f output will be in terms of the third input here, that is z here. So z possibilities into z will be equal to z bar 0 and 1. So these are 4 possibilities here. Diagram will be like this. So draw the diagram. It will be like this. Diagram. So 4:1 multiplexer. So we'll be having only one input, that is f. 2 selection lines, those are equal to x, y. And with the help of these 2 selection lines, we'll be getting 4 input combinations here. So x, y 0, 0 is the selection lines. So these selection lines S1, S0 అనుకోండి. So it is selection lines. So this is the first 0 input, first input, second input, and the third input. XY value 0, 0 అయితే, XY value 0, 0 అయితే, so I'll get the first input as f is equal to z here. 0, 1 అయితే z bar. So 1, 0 అయితే 0, and 1, 1 అయితే 3. So this is the diagram, which is simple. So multiplexer, it is how multiplexer is implemented. Clear?
Yeah, sir.
Yeah. So take one more diagram, so you'll get it clear. So one more problem. So everyone clear with this? So inputs ఎలా వచ్చాయి అంటే, so based on the values of selection lines and based on the values, comparing the values of this f and the last input here, that's z here. Right?
Yeah, sir.
Yeah. So take the another problem. Your confusions will be gone. So f is equal to f of, so a comma b comma c comma d is equal to sigma of 1, 3, 4, 11, 12, 13, 14, 15. 1, 3, 4, 11, 12, 13, 14, 15. Okay, so this is the problem here. So first of all, what are the selection lines?
A, B, C, D.
Selection lines over 10. So earlier f of x, y, z చెప్పినప్పుడు I told that x, y are the selection lines and the output f will be in terms of z. So z is not a selection line there. So here when you are given like
ABC, sir.
n
sir.
lines here, so A, B, C are the selection lines and output will be in terms of d here. So d bar 0 or 1. అంతే కదా? Yes or no? So generally selection lines are ABC. The output will be, I mean, what are the inputs will take? F will be in terms of, what are the inputs will take? F will be in terms of d bar 0 or 1. Okay. And when there are 3 selection lines, the multiplexer implemented is using 8:1. Clear?
Yes, sir.
Yeah, sir.
Right. So first of all, what we have to do? So we have to draw the truth table. Okay. So truth table with the values of A, B, C, D. First, write all the values from 0, 0 up to 15. That is 1, 1, 1, 1. So these 8421 codes, it should be perfect. So first మీరు 15 వరకు నేర్చుకోండి. So 1011. Sorry, it's 1100. 1100. It is 12, 13, 14, 15. Okay. Now what we have to do here is, so we have to divide the selection lines based on the values of ABC. We have to divide the similar selection lines based on the values of ABC. Okay. So similar selection lines in divide చేయాలి. That is 0, 0, 0. We have to group the similar selection lines. Okay. 0, 0, 0, 1 ABC, 0, 1, 0, 0, 1, 1, 1, 0, 0. Okay. So 1, 0, 1. So 1, 1, 0 and 1, 1. Okay. And this is the group like output will be F here. So F will be compared with D. Okay. So ABC columns are the selection lines here and F is compared with D. And what are the values of F here? So these 1, 3, 4, 11, 12, 13, 14, 15 values are 1 and remaining are zeros. So 14, 15 values are 1. 13 value is 1. 12 value is 0. So 12 is also 1, right? So 12 is also 1. 11 is also 1. And there is no 10. So 1, 3, 4. So 0 is 0. 1. This is 2, 3, 4, and remaining all are zeros. Okay, so these values, f values is based on this value given Boolean function value. Okay, so 1, 3, 4. This is 0. This is 1, 2, 3, 4, 11, 12, 13, 14, 15. So 1 value is 1, 3 value is 1, and 4 value is 1, and remaining all are zeros. And from 11 to 15, all the values are equal to 1. So 11, 12, 13, 14, 15. Okay, now what we have to do, we have to compare this f and d. So check the last 2 columns only. So f and d are compared here. So what is the value of f here?
D,
So what
sir.
is the value of f?
D.
So f and d are compared here. So f and d are compared. So f value is equal to d. Okay, the value of f is equal to d here. And here the value of f is equal to
D, sir. Again.
also equal is equal to d. So second input is also 0, 1 input is d, and selection line 0, 1, 0.
D.
So 0, 1 వచ్చింది,
D,
0, 1 వచ్చింది. So
inverse.
this is equal to d bar. And here, irrespective of the value of d, the value of f is equal to
0,
0. And here also, the irrespective of the values of d here, the value of f is equal to 0.
0.
Okay. And here the value of f is equal to d,
D, sir.
because both are equal. And here the irrespective of the values here, f is equal to 1,
1.
and here f is equal to 1. So these are the 8 inputs here. So d, d bar, 0, 0, d, 1, 1. Okay. Now we have to draw the multiplexer here. The multiplexer is drawn. So 8:1 multiplexer. So 3 selection lines that are A, B, C. So A, B, C are the 3 selection lines. And 8 inputs here. So 1, 2, 4. Right. So 0, 1, 2, 3, 4, 5, 6, 7. I will be having only one output, that is equal to f. So 8:1 max here. Okay. The first one is D, and the second one is also equal to D. So just I'm giving a connection here. And the third one is, that is the 0, 1, 2. So it is a inverter. I'll put an inverter here, or you can write D bar also, no problem, or I'll put an inverter. So next one is 0. Okay, and this is also equal to 0, right? The fourth input is also equal to 0. That is 0 inputs, 2, 3, 4, 5, 6, 7. Okay, so these two are equal to zeros, third and fourth. So fifth one is again D. Okay, and sixth and seventh one are 1 here. So this is 1. I can tie these inputs here. Right. So these are the 8 possible inputs here. So D bar, 0, 0, D, 1, and 1. Clear?
Yes, sir.
Yeah. So now what you have to do, you have to design a circuit. So I'll give a problem. It will be the same case here. So design a full subtractor using multiplexer. So take down this problem. design a full subtractor. Design a full subtractor using multiplexer. So better design. So actually, this multiplexer full subtractor will have two outputs. We'll use two multiplexers here. So one for sum, one for difference, other one for borrow. Okay. So first draw the truth table. Still many people are joining. So draw the truth table for full subtractor. So the concepts are very simple, but you should have some presence of mind and more practice. So design, or you can be given like realize and design a full subtractor. Right. So we'll use two multiplexers. 4:1 అనుకుందామా? Yeah, two multiplexers are used with 4:1 multiplexers used because first of all write the truth table, then we'll design, right? So the inputs are like this. So difference and borrow. First draw the truth table. Okay, so for this difference and borrow, it is 0, 0. So what I'll do, I'll do an elaboration of this because I'll tell you. Difference, two outputs. These are the two outputs here. So I generally multiplexer has one output. So here we have two outputs got it. We need two multiplexers here. And here it is. Difference is 1 because 0 minus 0 it is 0. 0 minus 1 it is difference is 1 and borrow is 1. And 0 1 0 here also the same, difference is 1, borrow is 1. And 0 1 1 so difference is 0, borrow is 1 because 0 minus 1 difference 1, borrow 1. And again we have to subtract 1 from difference, so hence we get a difference of 0 and borrow of 1. So 1 minus 0 it's 1 of difference and borrow of 0. So 1 0 1 both are zeros, so difference 0, borrow 0. And 1 1 0 is the same thing, difference 0, borrow 0. So 1 1 1 Same thing like, so difference is 1, borrow is 1. 1 minus 1, 0, 0 minus 1, difference is 0, borrow is 1. Sorry, difference is 1 and borrow is 1. Okay, so these are the inputs here, like, so x, y, z. So three possible combinations here. So out of this, x, y will be the selection line. Okay, so just like the previous case here. So x, y will be the selection line. So group the similar selection lines. So x, y, and outputs will be in terms of z here. So difference and borrow will be in terms of z here. Okay. Getting my point? Right? Now check
Yes,
the
sir.
values of d and z here, and also b and z. Okay. So here the value of d will be equal to, so d is equal to the same thing, z. So compare d and z here. So here d is equal to z bar. So here d is equal to the same thing, z bar. Okay, and here d is equal to z. So this is the inputs of the first multiplexer. Okay, and coming here, so b is equal to, so tell me the value of b.
Z.
Z, and here b is equal to,
1.
yeah, 1, because here it is 0 1 and here it is 1 1. So we got both the values here as 1. So here b is equal to 0, and here b is equal to, again it is a z.
Z.
So first of all, this is the first step we have to do, and we are having two outputs. We need two multiplexers here, and what is the size of multiplexer? It depends upon the selection lines we are using. Selection lines, we have two selection lines, so hence it is a 2 4:1 multiplexers. Okay, 2 4:1 multiplexers. Okay, so this is the first multiplexer, and this is the second multiplexer. The selection lines are same for both the multiplexers here. Selection lines are x and y. Selection lines, this is S1, S0, and this is S1, S0. So the value of x, the value of y. This is given to x and this is given to y. Okay, and it is a 4:1 multiplexer, right? So one is D output, other one is the borrow output. Okay, so the four inputs are difference and borrow. Okay, the four inputs for difference and borrow here. So it is 0 0 0 1, selection line 0 0 0 1 1 0 1 1. In a similar way, here also we have selection line 0 0 0 1, so 1 0 1 1. Okay, for difference, the inputs are Z, the first input, and next one is Z bar. So give a inverter or just write it, no problem. And the next one is also Z bar. So just join these two. Okay, and the last one is again Z. So drag this and join this. Okay, so here it is Z 1 0. So again it is a Z. The value is again, it's a Z here. The last one is Z. and don't join this. Like there should be gap. Wait. Okay, so this is 1, this is 0. So this is how we implement the full subtractor using multiplexer here. Clear?
Sir.
Yes, sir.
Right. In similar way, we can implement a full ladder. Right. So take that as an assignment. So there, here we got some that is difference on borrow. There will get some on carry. Okay. So take that as assignment. So design or realize a full ladder using multiplexer. Clear?
Yes, sir.
So any doubts in this concepts?
No, sir.
Any doubts, please let me know. So we'll see like higher implementations also, like so we'll see how to implement the higher order multiplexers using the low order ones. Okay. So this is the method for implementation of any circuit diagram using the multiplexers. First of all, identify the selection lines, and output should be in terms of the last 1 year. So that is a last given variable year. So difference or borrows, when we have multiple outputs, we have to use one multiplexer for each and every multiplexer. I mean each and every output here. Okay, because multiplexer means that it is a single output. So multiple inputs. Clear?
Yes, sir.
Yeah. So we'll see the next method of problem. So take down this. Implement. We'll start with the small one. So 8:1 multiplexer. Implement 8:1 multiplexer using 2:1. Using 2:1 multiplexer. 2:1 MUX and yeah, using 2:1, and we had to use 4:1 also. So we'll see how this 4:1 is used here. Okay. So 8:1. So here decoder like output check chesamu. So here what we have to do here is we have to check the inputs here. Okay. So 8:1 multiplexer using 2:1 ante. So we had to use 4 2:1. Okay. So the 4 2:1 multiplexers. So the first one, second one, third one, the fourth one. Okay. 4 2:1 multiplexers. So 4 multiplexers ante. So we'll be having each one is having 8:1. So 2 inputs, right? So this is I naught. So each one is having 2 inputs. And each one is having output here. So what output I can put it as here? So x1, and I'll get it as x naught, x1. So this is x0, this is x1, this is x2, this is x3. Okay, so inputs are I0, I1, I2, I3, I4, so I5, I6, I7. So what are the selection lines for each multiplexer here? So only single selection line, because it is a 2:1 multiplexer, we'll be having only a single selection line here. So single selection line given to all the 4 multiplexers here. That is S. This is also S. This is also S. This is also equal to S here. Okay. So fine. But here what we have to do here is, so the output should be from any one of the 1 multiplexers here. Okay, so what is outputs? What I'll do, so I need 1 output in total. So ఇక్కడ ఏంటంటే x0, x1, x2, x3, so 4 outputs వచ్చాయి. 4 outputs కాదు కావాల్సింది, 1 output కావాలి. So what I'll do, I'll give this 4 outputs as inputs to the 4:1 multiplexer. Again, I have to use a 4:1 multiplexer, whereas these 4 outputs are from the okay, this is x0, x1, x2, x3, and this is a 4:1 mux here. Okay, a single output, I'll make it as y here, so capital Y. Okay, and selection lines will be having another 2 selection lines. The selection lines, I'll put it as so here I'll take it as S0. Okay, so instead of taking this as this one, I'll take it as S0 here. This is S2, S1. Okay, so based on the selection lines S2, S1, so one of this will be selected here. Okay, so for example, so ఇప్పుడు ఏం చేస్తానంటే నేను, so the values of S2, S1 is equal to, I'll make it as 1 0. So 1 0 అయితే ఏమవుతుంది, S2, S1 1 0 అయితే, so what is the output by here? What is output by?
x2.
So when S2, S1 is equal to, so 0 0 అయితే S2, S1 0 0 అయితే x0 will be the output here. So y will be equal to x0. Yes or no?
Yes, sir.
So when it is equal to 0 1, S2, S1 is equal to 0 1, so y will be equal to x1. So when it is 1 0, so y will be equal to x2. So when it is 1 1, y will be equal to x3. Yes or no?
Yes, sir.
Okay, so here S2, S1 is 1 0 ante y is equal to, y will get the input from the x2. So x2 కి వెళ్ళాలి నేను. Okay, so x2 లో ఏది మరి, it depends upon the selection line S0 here. It depends upon the selection lines S0. So if the selection line S0 is equal to 1, if the selection line S0 is equal to 1. Okay, so if selection line S0 is equal to 1, so what happens here? So S0 is equal to 1 అయితే ఏమవుతుంది? So it is 0 అయితే I4 select అవుతుంది. So 1 అయితే I5 select అవుతుంది. So x2 will be equal to, so this I5 is directed to x2. Okay, so y will be equal to, now the value of y will be equal to I5. Clear?
Yes, sir.
Okay,
Yeah.
so just the
Yeah, sir.
values of selection will decide the what is the input is given as output here. Okay, so general ga S2, S1, S0 1 0 1 అయితే 5, so I5 should be the output. So మీరు అదేం చెక్ చేయాలంటే మీ బ్లాక్ డయాగ్రామ్ లో అది వెరిఫై అవుతుందా లేదా చెక్ చేయాలి. Okay, so if I take the selection lines as 1 0 0, sorry 0 1 0. Okay, so 0 1 0 అంటే S2, S1 0 1 అయితే ఏమవుతుంది, so if it is 0 1, so x1 will be selected, so y will be x1 here. Okay, and x1 will go to the x1 here, so back tracing, this is back tracing here. and S value will be equal to 0. So S value 0 aithe it will select I2. So if it is 1, it will select I3. So the value of X will be, sorry. Yeah, 0 aithe I2 is selected, and 1 aithe I3 will be selected. So this 0 since I2 is selected here. So Y will be equal to I2. Clear?
Yes, sir.
Okay,
Yes,
so
sir.
please understand it. It's a simple concept, but there are a lot of things to understand. Gavati, we have to do more and more practice.
Okay,
Okay.
sir.
Yeah. So now what we'll do? So we'll implement. So we'll take the same problem again. We'll take another kind of problem. So implement 16:1 multiplexer. Using 4:1. 4:1 MUX. Okay. So implement it. So first input size we need 4:1 multiplexers, that is common. So first thing what we have to do, the first one, second one, third one, second, third, and fourth. Okay, so we need 4:1 multiplexers. So 4:1 multiplexers will be having two selection lines, right? So we'll be having two selection lines, and each multiplexer is having 4 inputs. One, two, three, 4. 1, 2, 3, 4. And selection lines will be equal to S1, S0. The same selection lines are S1, S0, and S1, S0. This is S1, S0. Right, this is S0, S1, S1, S0. So each multiplexer 4 inputs. So 16:1 multiplexer got I0, I1, I2, I3. So I had to write up to I15. So this is I15. This is I12, 13, 14, 15. The I12, I13. This is I14. Okay. Similarly, so I4 to I7, I8 to I11. Okay. So and each multiplexer is having a single output. I'll make it as the same case, like X1, sorry, X0, X1, X2, X3. Okay. So all these are given to another 4:1 multiplexer, because we are having a 4 additional outputs. Gavati, I have to make this output as 1 here. Okay, S2, S1, and I'll make it as S3, S2 selection lines, and this will be the Y here. So this will be X0, X1, X2, X3. Okay, so for example, if the values of S3 S2, S1, S0. So first of all, we have to check the values of S1, S0 anukundamu. Okay, the values of S1, S0 is so 10 anukundamu. Okay, so 10 values of S1, S0 10 అయితే ఏమవుతుంది? So each one will be having 10, right? So first of all, the value of S3, S2 is important. So S3, S2 is also equal to 10 anukundamu. Okay, so if S3, S2 is 10, okay, so what happens here? So if it is 0, S3, S2 is 0, 0, we will select X0 here. If it is 0, 1, X1 is selected. So if 1, 0, X2 is selected. Okay, so X2. Okay, so here S1, S0, again S1, S0, X2 S1, S0 is equal to 10 అయితే ఏమవుతుంది? So I8 is 0, 0,
I10 okay, sir.
10. So it is I10. Okay, so I8, I9, I10. Okay, so the value of Y will be equal to I10. Clear?
Yes, sir.
Yeah, sir.
Okay, so if we give the same question, implement this 16:1 using 2:1 multiplex అన్నారంటే ఏమవుతుంది అప్పుడు చెప్పండి? Using 2:1 అంటే I'll be using 8 2:1. Okay, I'll get 8 outputs like X0 to X7. Okay, so what I have to use here? So X0 to X7, 8 outputs. I got out to make it as a 8 outputs as a single output. So what I have to do? I'll give this X0 to X7 to a 8:1 multiplexer. X0 to X7 to a 8:1 multiplexer. Yes or no?
Yes, sir.
Okay, so this is how we deal with this. Okay, so now take the problem. Next problem. So implement 64:1 MUX using 16:1 and 4:1 MUX. Okay, so 64:1 using 16:1 ante, so 16's 4's are. So we have to use 4 16:1s. The same case 1, 2, 3. So 64 and 2 power 6. So we need 6 selection lines here. Okay, so we'll be having the first one will be having inputs from the first multiplexer have inputs from I0 to so I15. Okay, so each one is having 16 inputs here. So I0 to I15. So now space సరిపోక రాసినాను మీకు కావాలంటే అది వేసుకోండి. So I can write like this. So the meaning of this series of inputs here. So 16 to 31 and here I32 to
I47.
47 and the last one is so I48 to 63.
63.
Okay, so 4 multiplexes and this will be having 4 selection lines. So S3, S2, S1, S0. So each one will be having 4 selection lines. S3, S2, S1, S0. Okay, and 4 outputs like X0, X1, X2, and X3. Okay, and these 4 selection lines are given to additional 4:1 multiplexer. Okay, the 4 outputs are given to additional 4:1 multiplexer and additional 2 selection lines are used here. S0, S3, S1, and here we'll be having S5 and S4. Okay, so S5, S4, 0, 0 అయితే X0 is selected. S5, S4, 0, 1 అయితే X1 is selected. S5, S4, so 1, 0 అయితే X2 is selected and S5, S4, 1, 1 అయితే X3 is selected. Okay, so in X3 it depends upon the values of S3, S2 2, and I mean, if I take the values like this, so S5, S4, okay, so the value is like this. So 1 1 0 0 1 1. Okay, so first S5 S4 is 1 1 ante artham enti? So y will be equal to x3. So y is equal to, so y is from x3. Okay, so in this one, the values are like 0 0 1 1. So 0 0 1 1 ante it is third value of this x3. So 48 is the 0, and 49 is 1, 50 is 2, and 51. So the output y is equal to, so I 51. So when the selection lines are this value. Clear?
Yes, sir.
Yeah, sir.
So the one thing should be clear here is, selection lines ఎక్కడెక్కడ యూజ్ చేసాము. సో అవుట్పుట్స్ మనకి ఎన్ని వస్తాయో అంత సైజ్ మల్టీప్లెక్సర్ మన అవుట్పుట్ సింగిల్ చేయడానికి యూజ్ చేయాలి. సో ఇఫ్ ఐ సే దట్ ఇంప్లిమెంట్ 64:1 యూజింగ్ 32:1 అంటాను. సో 32:1 అంటే 2 multiplexers are needed here initially. Okay, so 2 multiplexers, 232:1, and we'll get 2 outputs from the 2 multiplexers, and those 2 outputs are given to another 2:1 multiplexer. Clear?
Yes, sir.
Okay, so or
Yes, sir.
if I say that implement 64:1 using 4:1 multiplexer అన్నాను అనుకోండి, so what happens, I need 16 4:1 multiplexers. Okay, 16 4:1 multiplexers, and we'll get 16 outputs from this 16 4:1 multiplexers. So I need an additional 16:1 multiplexer in order to make all these 16 inputs as one output. అంతే కదా?
Yes, sir.
Okay, if I say that implement 64:1, I mean, how many multiplexers, how many 4:1 multiplexers are needed to construct 64:1 multiplexer antanu. Okay, or else so I'll just give a number, how many 4:1 multiplexers are needed in order to construct a 16:1 multiplexer. Okay, so what is the answer? So how many multiplexers, 4:1 multiplexers are needed in order to construct a 16:1 multiplexer? So how many multiplexers are needed? We need 5 4:1.
5.
Yeah, 5. So 5 4:1 multiplexers. So this is how we have to understand. Okay, so main thing is you have to understand the concepts like this. So in different ways, so solve the different problems, and you'll get the different perspectives and different understandings here. Clear?
Yeah, sir.
Yes, sir.
Fine. So we'll stop it for today. Okay. So we'll take classes every day. I don't know whether by what time your offline classes will be start. So I want to make it fast. So I'll be taking classes every day. Okay. So daily I'll be taking, I don't know how many classes I'll take. So based on the time and things, I'll be taking more and more classes. So minimum of 2 hours. Okay. And I'll be sending the recordings also. Wait, I'll show you the syllabus of you. Yeah. So combination circuits. So we are seeing the introduction and analysis part. I have told you in the first class. I'll Mari chudamu. Mari inkokasari we'll see the analysis part and design part. So we are seeing the small adders, full adders, half adders, full subtractor, half subtractor, and we have seen the concept of decoders. We have seen the concepts of multiplexers here. Okay, and next we'll see the code converters or encoders. Okay, so the concepts of encoders we'll see. We'll see the code converters, what are the kinds of code converters, and next we'll see the remaining things. It will take hardly around 7 to 8 classes to cover all these things. Okay, so I'll complete this combination circuits. Okay, so once did with the combination circuits, what I'll do, I'll not start the sequential circuits. Okay, I'll start this PALs. So there is no connection between combination circuits arthamaithe chalu, see arthamaipotundi. Okay, so we'll see this concept of PALs and all. Okay, so then sequential circuits will start with the sequential circuits. So sequential circuits is a very larger one. So I need a continuity for that. Okay, and meanwhile, while finishing this one, after finishing this one, we'll start with this memory and PALs here. Okay, so then we'll see the sequential circuits. Okay, so minimum of 2 classes needed every day from right now. Okay, so we prepare for that. So be prepared for that, 2 classes every day. Okay, if
Okay.
offline comes, we'll take more classes, 2 or more classes also. Okay, I don't know when the offline classes will start. So February 1st or but don't know. I'm not sure about it. Clear?
Yeah, sir.
Yeah, drop your attendance and yeah, see you tomorrow for sure in the morning session.